So I saw this cracking animation by Surab done in Houdini. So I thought maybe we could do something like this in Blender. So you have a ground here and it breaks depending on the curve you have. So if I say, and you can also add it to non-flat objects like this donut here. So you can crack that. It could be anything. So let's see how we can set it up. We're going to start with a plane, scale it, maybe add a few subdivisions. Subdivide this procedurally using a subdivision surface. Keep it simple, and I'll also turn off optimum display so that I can see the wireframe. Subdivide a few times, add a particle system like this. This is going to be used in conjunction with the explode modifier so that we have some islands or fractures that we're going to use with geometry nodes. Let's remove the physics or gravity and everything. So I'm going to go to field weights, remove the gravity, go to the velocity, make sure that is also set to 0. And the start should be something like 0.5. The end should also be 0.5. The life, as long as the timeline doesn't matter. So if we play back, we don't really see much, but we are not seeing the particles falling anymore or having any animation, and that's what we want. If we add a new geometry nodes modifier to make sure that the fracturing is working, you can come here and add a scale elements and scale the faces to see how the faces have been fractured. The islands are squares, which is not what we want. But first, let's remove these particles from this so that they don't display. So we can go to render preview, set that to none so that we can see everything. Now we can go back here, add a decimate modifier. And if you look at the explode, there is this cut edges option. It cuts the edges randomly. And you can also use a decimate above the particle system to make the pieces even more random. Add a curve now. We're going to use this for the path of our fracturing. And I can come back to this here and bring in that curve as an object and use geometry proximity. We want to move the pieces nearest to the curve a little bit up. So we can use the distance and use it to set the position. And let me use a combine XY just to affect the Z position of this. So we're getting an error because this is a curve. We need to change it to a mesh. So I need to convert this to a mesh, curve to mesh, and use a curve circle as a profile. I can reduce. So you can see what we're having. We can also use color ramp to control how this is mapped. So something like this. So let me reduce the radius a bit here. You can even blur this attribute, so that we have something like this. Now, without these scale elements, we get something like that. You can already see the cracks and everything. I'll continue reducing the radius. Now, if you want, you can just push this up using a math node. Multiply. We need to flip this. Something like that. And I use a math node to just scale this down a bit. So if you want it to go down, if you want it to go up. Another thing we could do is try to rotate the individual pieces as we fracture. Let me make sure that this is set to relative. So that we match the position of the curve. We are almost done because right now you can just even add a curve trim here before you convert this to a curve. So around here, and you get something, but we are not done yet. So we can rotate the individual pieces a little bit depending on how close they are to the curve. And unfortunately, there isn't a way to do that easily. For example, if I wanted to rotate this, since this is a mesh, the only way to do that is by using the transform, but that will rotate the entire mesh. If you turn this to instances, geometry to instances, then this becomes a single instance. So if you try to rotate instances, then still it's going to be rotating the entire block. In Blender 4.1, there is an option to turn each island into an instance, but the problem with that, the instances all have their location at the center, so you will still have the same results as we have here. Another way that I found to work was to use the accumulate fields, and the way you do it, you accumulate the centers of each of these islands and then use them as the rotation center if you're rotating. So what we can do is use a set position and try to rotate the position of each island using the vector rotate. You can change the axis to Euler so that we are dealing with degrees. So if I rotate this, you can see we get a rotation, but we are rotating the entire thing. So we want to make sure that the center, you can see, is set for each individual, so that when we are rotating this, each island is rotated from its center. And to do that, we can accumulate the centers of each island into fields that we can use for the center. We are going to use the mesh island and the accumulate field. So we want to accumulate the position of each island. So we get the group ID or the island ID, and we want to match the accumulated position to the island. So I'll just accumulate the island count. So I can just change this to integer and just accumulate by 1. To get the centers of each index, we can just use vector math and divide the total positions accumulated with the total index accumulated here. This will give us the centers of each island we have here. So if I connect this here, now you can see that each island is being rotated individually, which is exactly what we want. And if I use something like a random value, should be a vector, connect this here, you can see each island should get a unique rotation, but we need to make sure that this random value we're getting is per island, so we can use this index as the ID. So now you can see that each island has its own unique rotation. Let me use a negative 1.57 and 1.57 for the minimum. We don't want everything to be rotated. We just want the islands close to the curve to be rotated. For that, I can still borrow this attribute here. I think I can just come here and just create a new one and just use this directly depending on the distance. So I'm going to change this to scale and have it here. So if we set this to 0, we don't really have any rotation. And I can even first remove this position we had before. And so you can see we can control the rotation here. So if I use the distance, you can see what we're getting is inverted. So I'm going to use a float curve, flip this around like that. And let's play with the trim here. So where's my group input here? Have this animated. Let's set a keyframe there, and keyframe at 100. We can have this set to 0. If you set this to 1, it snaps back or creates a bug. So make sure it's just 0.99 instead of 1. And now you can see we have that. And let me also bring back this position. Now we can give this a road texture. Let me go to my texture folders and go back to my materials and go to my roads folder. And let me use this, import this. That's our road, but it lacks thickness. Let me create a new material. Go to geometry nodes. We can come here and extrude just like that. Yeah, and now we can use a set material. This time, let's use material 2 and use the selection from here. This should be the side, and you could see what we have now. We have procedural cracks. And you can change quite a lot of parameters from how big these cracks are. So if I reduce the subdivisions, you can see we get some pretty big cracks. Them super small. And you can also push this down so that when it's cracking or it's caving in. Now remember, all this is procedure, so at any time I can change the path. You get something like that. So you can see VFX and destruction like this takes a lot of time to figure out. But if you don't want to do that and you just want to do VFX right away, the RBD Lab is an add-on that comes with a lot of template for metal deforming, fracturing, and anything that has to do with VFX. They really put in a lot of time in this add-on, and I really recommend it. So if you want to check it out, links are going to be in the description. Yeah, you can use it for any form of distractions and destroying objects. Thank you for watching. If you want to get the project files and find it on my Patreon page, Gumroad, all links are going to be in the description.